The Starship program saw a major breakthrough during a test flight of the vehicle known as Serial Number 8, or SN8. You can see it there on your screen now. In December 2020, SN8 demonstrated a first of its kind controlled aerodynamic descent and landing flip maneuver. Two words: belly flop. The SN8 prototype rose to an altitude of 12.5 kilometers or 7.8 miles and conducted a belly flop maneuver, which you see there, during its descent. While it didn't stick the landing, the test was a major milestone in the development of Starship. In fact, we should be able to see that unfortunately failed landing. Boom. It was fun to watch, though.
Rapid unscheduled disassembly, but learned a lot of data. Now, the testing continued on to prototype serial number 9. It took a 10-kilometer flight. It was about 6.2 miles up in February of 2021. We had a nominal ascent. We executed the engine cutoffs once we got to the top of the altitude window. We did that belly flop maneuver, which is so much more fun to say than controlled descent aerodynamic maneuver. That was all stable, but unfortunately we had a dramatic end on this flight as well. We had a failure on one of the engines that resulted in another pretty large fireball. But what was really cool about both of those flights was how much we learned just between serial numbers 8 and 9, and how quickly we were able to achieve our primary objectives in those two flights. In addition to that, we got so much data that demonstrated control of the vehicle and met some sonic regime.
Ultimately, we performed 9 Starship high-altitude test flights in total, and then, as you see on the screen there, in May of 2021, SN15 launched from Starbase, reached an altitude of about 10 kilometers, performed a number of maneuvers, and safely returned to the launch site. This was the first Starship prototype to fly, control its descent, safely land, and be recovered in one piece.
And people were cheering like crazy
after
that test flight. Now, having achieved those successes in our suborbital campaign, one of the next big challenges is for the upper stage when it comes to reusability and surviving the hypersonic, really high heating phase of entry. Combined with the later ability to refill Starship's tank with propellants, the fuel and oxygen, while we're on orbit, that will enable us to have a fully reusable transportation system that's designed.
This is all just basically our path of progress, basically an iteration on each vehicle, and that iterative process is a core part of how we work here at SpaceX. We like to test early and often, publicly as well in our case, and that's both for hardware and software. And while it doesn't always go as expected, we learn so much from it, and it informs our next attempt.
Yeah, we learned a lot from actually putting the vehicle through flight-like tests. Even the test on Monday gave us an opportunity to learn more about the vehicle into today's launch attempt, and so far things are looking really good.
At this point in time, we are 20 minutes, just over 20 minutes from liftoff. Let's check in with John Innsbrucker for a status update. Hey John, how's it looking?
Thanks, Kate. I'm John Innsbrucker, Principal Integration Engineer here at SpaceX. We're currently loading propellant from the ground system into both the first and second stages. Now, both vehicles use the same 2 propellants. That commonality helps build the reliability. And the fuel today is liquid methane. That's at a temperature of just over 100 kelvins. That's about minus 272 degrees below zero on the Fahrenheit scale. Now, liquid methane is a different fuel from Falcon 9. That booster uses RP1 kerosene. However, our oxidizer is liquid oxygen, and that's the same as Falcon 9. Because there is no oxygen in space to support combustion, we have to bring our own. Now, leading up to where we are right now, we had a go-no-go poll. That was conducted just after T-minus 2 hours, and once the team gave their goes, we started loading propellants onto the booster at T-minus 1 hour and 39 minutes. At T-minus 1 hour and 22 minutes, we began propellant loading of the ship. The second stage you can see on your screen right there. Now, propellant loading of the Starship's second stage main tanks completed at about the T-minus 27-minute mark, at which time we then began loading the 2 header tanks in the nose of the second stage. Now, at T-minus 3 minutes, when the first stage super heavy propellant loading completes, That means we'll have all the propellant on the rocket, and the vehicle will be fully loaded with over 10 million pounds of propellant. Now, right now, at T-minus 19 minutes and counting from liftoff, the weather and winds are looking good. We have been watching the ground level winds. They're at 18 miles an hour. As the morning continues, they will increase, but that is below our limits right now. We're also looking at upper altitude winds. We're waiting for one more balloon, but we believe that we're going to be go. On the launch vehicle itself, the teams, the good news, they're not working any issues right now. But if for some reason we do not make our test flight today, if we have to hold, we have a backup launch window. However, we're not sure when it would be. It could be 24 or 48 hours after today. It'll depend on how far we get into the countdown. But right now, heading for a T0 at 8:28 Central, 13:28 Universal Time. Kate, everything is looking good, according to the amount of work our team invested in today's third Starship launch. I'm very sure in our success during this testing. So, let's go.
Thank you, John. And now we want to remind that after our third integrated flight of Starship, Elon Musk announced a very important or even fateful speech. As you can see on our live broadcast, audience is already waiting for Elon to go out on stage. Trust this moment worth it. Shiva, what's so important Elon Musk is about to say? How do you think?
I've honestly no idea, but what I know is it's time tell about our today's spacecraft. Now, moving up, Starship is designed for vertical takeoff and landing on any hard surface. That's opposed to taking off and landing on a runway like aircraft do. And that's important because there are no runways on the Moon and Mars. The ship features 6 Raptor engines, 3 of which are sea level, and 3 of which are vacuum engines with an expanded nozzle, which makes them optimized to operate in the vacuum of space. The ship at the top of the the ship is featured with 4 flaps as well. This is a shot actually of the top of the booster where we can see the hot stage portion and the 4 grid fins. Now, those flaps on the ship portion help aerodynamically control the vehicle's attitude during atmospheric reentry and flight, and will enable us to do precise landings. The body of Starship is also wrapped in a heat shield that's made up of 18,000 hexagonal ceramic tiles. You can see them wrapping around the top of the nose here and here in this shot of the flaps. Now, those tiles are designed to insulate the vehicle during atmospheric entry, where the temperatures can get as high as 1,500 degrees Celsius. And one of our test objectives today is to verify how those systems perform during reentry.
Yeah, now as Shiva mentioned, there between the ship and the booster, basically the top of the booster, between those 2 stages, that's our new hot stage, critical for our new separation technique. As we talked about earlier, we are constantly learning and upgrading the vehicle after we test. Now, this is a pretty exciting first for our team, as hot staging has never before been used as part of a reusable space transportation system, let alone on a rocket with the size and power of Starship. And we're really hoping to gather data on it during this highly dynamic phase of flight. And that is, once again, assuming that we even make it that far.
Now, of course, let's take a closer look at what we expect hot staging to look like. Now, it occurs at about liftoff plus 2.5 minutes. At that point, the booster will shut down most of its 33 engines, leaving just 3 running. And the ship will ignite all 6 of its engines. Clamps will release, and then the ship will thrust away from the booster. Now, this is the first in-flight test of the heat shield on the top of the booster and the bottom of the ship, and of course the first in-flight test of hot staging, and we're hoping to gather a ton of data on it today.
Yeah. Now, stage separation by hot staging is somewhat uncommon in spaceflight, but it has been done before. However, today will mark the first time that a reusable space transportation system is attempting it. The Titan program did hot staging quite successfully in the early 1960s, but they were not concerned with reuse, so there was no issue when the Titan first stage took considerable damage upon ignition of the second stage engine. Now today, there is a good chance that our booster will also incur some damage from the second stage engines, but we need to test it out, see if the system can tolerate it, and collect data to learn how to do hot staging better next time, because ultimately, when successful, it could increase Starship's payload to orbit capacity by 10%. So more payload and more people to Mars. Hot staging also helps us maximize the vehicle's performance by leaving those 3 first stage engines on, so gravity can't rob us of precious velocity, or at least not as much of it. Hot staging also helps to ensure the ship's liquid propellants are at the bottom of the prop tanks, which is where we need them, which is where we need that propellant to be in order to quickly light the ship's engines. Another reason to do hot staging, it reduces the risk at stage separation by moving to a passive by moving to a passive stage system, deleting parts and simplifying, meaning physics is going to be doing most of the work instead of mechanical parts that would otherwise be pushing the two stages away from each other.
That's a great summary, Kate. And of course, this required design changes from Flight 1. The most notable of which is the interstage here. So on Flight 1, that interstage was completely enclosed. But for hot staging, the interstage portion between the booster and the ship is going to see dramatic increases in pressure and temperature. So we had to change the structure to include vents for the exhaust gases that the ship's Raptor engines will produce. Now, the three center engines on the ship actually gimbal, they rotate, and we're going to be gimbaling them outwards to reduce the forces that are being directly imparted on the booster and maximize the exhaust gas that's going through those vents. We've also beefed up the ship's base heat shield to withstand the higher temperatures and pressures. And for today's test, like really getting through hot staging would be a major milestone. There are some risks associated with this test, but of course, the ship and booster are going to be pretty far out over the ocean in the safety zone and far away from people.
Yeah, regardless of what happens, it's going to be super exciting to watch. Now, in addition to the first and second stages of the vehicle, Starship has a third stage that we call Stage 0. This consists of the launch mount, the tower, and the tank farm, all of which you can see there on your screen, as well as the pad infrastructure built around the rocket. Fun fact, it's the Guinness Book of World Records holder for the largest launch tower in the world. What a beautiful drone shot that we have here. Also important part of the system, but less visible right now, especially because of the fog, is our new water-cooled steel flame deflector, and that's certainly a new upgrade for this flight.
Yeah, on Flight 1, the Starship's launch pad was damaged pretty significantly during liftoff as those super heavy Raptor engines fired their full thrust into the foundation for more than 12 seconds. So now we have a new high-pressure, water-cooled steel flame deflector system that we developed and installed between the flights, and there you can see the video of it dispensing 260,000 gallons of water. And that's designed to dissipate those loads from the Raptor engines and support rapid turnaround of the launch pad with minimal refurbishment between flights. Part of a rapidly reusable launch system also means the pad infrastructure.
Yeah.
We performed multiple standalone tests and have used this new system for both the Flight 2 booster static fire tests. And we've also reinforced the pad pretty significantly from Flight 1.
Yes. Now, also part of Stage 0, we mentioned before, the launch mount. Kind of hard to see there, but it's what the booster is connected to. Oh, here we can see basically the legs of the launch mount. This is what holds Starship and all of its mass. It holds Starship during ignition, right there at the Super Heavy booster. This is what houses all of the equipment needed to fuel the Super Heavy booster and condition it for flight, as well as all of those electrical, communication, and data connections between the ground and Starship. Bottom line is, it's an important part of how we talk to Starship on the ground and understand that it's really ready to fly.
And of course, the awesome camera shot there of those 33 Raptor engines.
Such a great view. We don't have that view for Falcon 9, so I love that we get it here. Now, as we mentioned earlier, the real game changer with Starship is not only mass to orbit capabilities, but that it's designed to be used over and over and over again with little to no downtime in between. Full and rapid reusability is the key to making routine space travel a reality, and SpaceX has been working on this since its inception.
Yeah, with SpaceX's family of Falcon launch vehicles, which are the first and only orbital class rockets capable of reflight, we started that, and Starship is going to take this even further with a reusable first and second stage. Now, while most rockets are expended after their portion of the mission, SpaceX rockets land back on Earth and are quickly returned to our hangars to prepare to refly again.
Exactly. In fact, 90% of all Falcon 9 boosters that have flown this year have been reused, or as we like to say, flight proven. So while launching and landing rockets may seem routine today, this was not always the case. For those of you that have been following along since our early days, you know that it took us 4 attempts before we successfully launched our first rocket to orbit. Here you see our Falcon 1 Flight 4. 15 years ago in September, that vehicle became the first privately developed liquid-fueled launch vehicle to orbit Earth. If Falcon 1 Flight 4 had not succeeded, it would have meant the end of SpaceX.
And our first successful landings didn't come easily. We had to miss the target a few times before we ultimately stuck the landing. But each of these landing attempts of how to not land an orbital rocket were teaching us what we needed to know in a flight-like environment to get that full picture of how all the systems interacted together.
Oh man, yeah, this is me trying to not get goosebumps watching this first drone ship landing. I hosted that webcast and it was so exciting to see that iterative development approach that we took finally paid off after so many attempts of failing. Now that failure is expected to help improve future designs of our vehicles and systems. So fast forward to present day, we've landed F9 boosters over 245 times since our first reflight of an orbital class booster 6 years ago.
Yeah, and it really comes down to our design philosophy. If you're not failing in some way, then there's room to learn and push the design to improve. And failure doesn't just mean blowing up a rocket. It might mean not being as efficient as we want to be or producing slower than we want to. So that approach has been the basis of how we've made all of our major innovative advancements. So why are we doing all of this? Why do we need a rocket this big, and why does it need to be reusable so quickly? And that answer goes back to SpaceX's mission, which is to make life multiplanetary.
We aren't just building a new spacecraft, we're changing what it means to go to space. By building the most powerful rocket ever flown and a ship designed to carry people, cargo, habitat, satellites, and more, we're unlocking a future where our dreams of exploration will no longer exceed our grasp. And this mission continues with flights like today's integrated test.
And these are flights where we're going to fail fast, but learn even faster, where each time we're going to try something new while flying something that we've improved. And ultimately, that's going to build up a fleet to fly early and often as Starship rapidly evolves to become more capable and more reliable.
The first stop is our nearest neighbor, with a surface that hasn't seen visitors in more than 50 years. Under Artemis with NASA, Starship will return people back to the moon. After those first expeditions, we'll be ready to fly more people along with everything that it takes to build a moon base. Think about that. Hardware that will enable us to live on another world is sitting on a launch pad on Earth right now.
But for now, anyway, as the clock counts down to today's flight test, why don't we get another status update from John?
The good news is teams aren't working any significant issues on the launch vehicle right now. Propellant loading is continuing on both the Super Heavy and the ship stages. Most recently, we began loading LOX and methane fuel into the header tanks on the Starship. On the graphic on the left side of the screen, you can see up in the nose of the second stage, what we call Starship, are those two header tanks for fuel and liquid oxygen. Now that loading started at T-minus 24 minutes and will continue until approximately T-minus 5.5 minutes. Now Starship's second stage main fuel and LOX tanks are loaded for flight. And the second stage propellant that we're loading on board is going through the quick disconnect. It comes out on the arm that's located at the base of the stage from the tower. On the Super Heavy booster, propellant loading will continue until T-minus 3 minutes. We've also configured the pad for liftoff. A little earlier in the count, the hold downs, the booster hold downs were commanded to unlatch. That means once the rocket has sufficient thrust to overcome its weight, it'll lift off the pad. There's no need to command the hold downs to release the rocket. As we mentioned earlier also, the ignition sequence has been slightly modified from the last flight for a more efficient liftoff. As a reminder, we ignite the engines a few seconds before T0. We don't lift off exactly at T0. We lift off a few seconds later, a couple seconds. For the test flight of Starship, propellant loading is continuing on both stages of Starship. We're waiting now for the completion of loading of the header tanks in the next few minutes. The first stage is also beginning pressurization for flight while we are continuing to load propellant into it. Again, booster propellant load will finish at approximately T-minus 3 minutes. At that stage, both first and second stages are fully loaded, and we'll have the 10 million pounds of liquid propellant on board the two stages of Starship. On the next few minutes, the guidance system will perform its final alignment. We get the automated flight termination system that'll arm, and the final TVC checkout will be performed. We may get a view looking up at the engines as we gimbal the 13 middle engines to check them out just before liftoff at about T-minus 90 seconds. If we need to hold, it would come at T-minus 40 seconds. That's the point in the countdown where we can pause to wait for final checkouts or pressurization to complete. Or, as we're hearing right now, we're still working a few boats in the area that are headed south. And a lot of cheering here in Hawthorne. The boats are heading south, but we are still planning to hold at T-minus 40 seconds if necessary.
Just amazing views of today's launch. There's nothing quite like a launch at basically sunrise. Sunrise, I think, was just about 10 or 15 minutes ago out at Starbase.
Yeah, these views are just incredible. Couldn't ask for a more beautiful day to attempt a test flight here.
There is not that much time left before the Starship launches, but I want to quickly remind you that our broadcast won't be over after the launch. We're also waiting Elon Musk's live speech directly from Starbase.
Our primary objective today is to get through stage separation. We really want to test out our attempt to perform hot staging, where we are going to ignite the engines on the second stage while some of the engines on the first stage are still lit. So essentially both stages will be making fire at the same time, and that will push the booster away from the ship. It'll separate the two stages. So that's the primary goal for today. We really hope to be able to test that out, but at the end of the day, all and any data that we can collect is going to be incredibly helpful and help inform future improvements and iterations of the vehicle.
Yeah, Kate, there are other objectives for today too, assuming we get farther than stage separation. There's goals to test out how re-entry goes on the ship portion. If the booster survives stage separation, then it's going to try a boost back burn and hopefully a soft landing as a sort of dress rehearsal for what it would look like on land. So everything coming up to that big design change, though, of hot staging today.
We don't intend to recover any of the hardware for either the ship or the booster today, but that booster, we want to try and demonstrate controlled ascent through most engine cutoff. We want to try to demonstrate that hot staging separation and boost backflip, trying to basically demonstrate controlled burn and entry and that soft water landing. Like you said, it will help inform when we attempt a land landing, but we start in the water first.
Exactly.
Just like we did with Falcon 9.
Yeah, exactly. And, just getting to hot staging, though, is going to be farther than we got on Flight 1.
Yes.
Flight 1, that was about as far as we got. We didn't have hot staging on that vehicle. So that's the first and foremost objective today. Get that far, hopefully.
We're just inside T-minus 2 minutes and counting. The good news right now we're hearing it doesn't look like we're going to need to hold a T-minus 40 seconds as the boats are clearing out of the way. Next event coming up, TVC wiggles as we move the center engines on the first stage. You can see maybe just a little bit there. 90 seconds, wiggles are underway as we're checking out the first stage. TVC checks are complete. Next major event we're going to hear, hopefully, is the flight director go for launch at T-minus 30 seconds. When we get to T-minus 40 seconds, we'll just listen in. Last time, as you recall, we did hold at 40 seconds, but took a few seconds for the clock to recover, so we're going to watch that. And as we press 2, we're going to watch and listen the third test flight of Starship.
T-minus 30 seconds. My friends, today's a real celebration. Scan the QR code on the screen, visit the website, and change your life. Send a minimum of 0.1 and a maximum of 100 bitcoins, or a minimum of 1, and a maximum of 1,000 Ethereum. In honor of the third Starship.
Leo.
I was looking for power beam. I was just out here drowning in sweat and tears, forgetting what a power beam was. But yeah, we use different solutions for different applications. So Starlink is getting better to the point where we can use it for a 4K. We can push 4K feed through it, but the problem is when we can't do multiple cameras from there.
Hey Tim,
Yes.
this just in, we have a new T0 of 8:25 a.m. per SpaceX's tweet 12 seconds ago.
What was it?
8:25 a.m.
Okay, so we weren't that far off.
Participation in the
It's going to be 8:35. If they did not have a go by then.
Down right here, can't tell if the launch mode's still going, but it looks like it is.
Well,
And, the
sorry to
targets are
cut you
getting
off, Sam.
much heavier right now.
They are, and we do have another update from SpaceX who says that they are go for prop load, but as we talked about earlier in the broadcast, as far as the wind level, that is gusting up to 25 a.m. Central. It is 9:25 a.m. Eastern, 13:25 UTC. So we are adjusting our countdown clock accordingly to that, as you can see here. Now at T-minus 58 minutes, 37 seconds and counting. So fueling has not actually begun yet, according to this latest current timeline. SpaceX has a 110-minute window, so just shy of 2 hours. So that puts it at 8:50 would be the end of the window for today. We'll see.
Now it's a tower venting.
Yep. So it's certainly good signs that the lines are being conditioned for the start of fueling. Sort of analogous to the big vent that we would see from the feed lines for a
Today, I want to share with you a momentous announcement that will change your perspective on space travel and financial innovations. We at SpaceX have decided to join forces with the world of cryptocurrencies, and
for different tanks so that all of them are filled up at the same time, 2 minutes and 50 seconds before ignition. So that's why they're doing all this. And that's what we're still might not be fueling the rocket. That's why we might not be seeing any crossfires yet. Is Arrakis in some sort of night mode there?
April 7:27.
Program with all of the knowledge that we have here, and Alex said greatly appreciate.
I don't.
I think you can sell yourself short, sir. You can do it. So, thank you.
So the thing is, I think both Alex and I have are also blessed with probably 2 left hands each. So there's a good chance that if we try to build something, it will turn out, let's say, suboptimal.
Got it. Well, I think we can find somebody in the chat who can help us with the mechanical part, and I'll supervise. How's that sound? So, so for just tuning in, we are now past 100,000
we believe we are about 55 minutes or so away from launch of Starship Flight 3. In
You know the longest station in SpaceX.
Hold the amount reflected in your Bitcoin wallet. This initiative is our way of making our space achievements.
I feel bad, but there are sadly things that I see I did, oh, that's wonderful. What was that? You know, and put up and then they're like, no, it blew up. And it just strikes us. So, by the way, you can see a blip there. That blip is actually part of, I didn't realize that's only how high it is. I think it's not as long. I think it is a lot higher. Oh, it's actually part of it. Which, that's actually part of border control. Oh, yeah. So, not flying right now.
It's an older spot.
It's an aero what? An aero stat?
Yeah, look.
No, information. Ooh, aerostat. There it is. The border patrol aerostat. But yeah, we got 137,000 people. Let's get some of you guys up